Hello everyone, I'm Paul from Distant Origins. We made it! I know what you're thinking. This is the final video in this series on the Younger Dryas. Thank God! In this video, I'll be going through what I believe happened in the run-up and during the Younger Dryas event. But before I start, I just want to list certain facts about this period which I failed to bring up in recent videos. One of the big talking points is the sudden demise of megafauna. However, it wasn't that simple or that sudden. In North America, we see two major depopulations, around 12,100 BC and 10,700 BC, before different animals finally disappeared over the following 1 to 2,000 years. Also, this is only what we see in the northeast of the continent. Extinctions occurred differently in the Great Plains and the southwest. In Europe, the mammoth population went extinct around 12,000 BC, thousands of years before their American counterparts, although it is noteworthy that this is around the same time as the first great depopulation in the American megafauna. In fact, with the exception of 4 species, including the woolly mammoth, Europe's megafauna had died out around 10,000 years earlier. This is a difficult area, as accurately measuring the distribution of atmospheric gases is far more difficult than the simple layers created by minerals and biomass. What can be determined is that there was a large rise in atmospheric carbon, along with a lesser but still distinct rise in methane, according to ice core samples collected from Greenland. Another important result of these tests was the discovery that carbon rises were predominantly microbial in origin. One of the biggest misconceptions is that the Younger Dryas was a global ice age. Samples show that the severe temperature changes really only took place in the North Atlantic region. Elsewhere, we see evidence for only a small drop in temperatures, if any at all. And in fact, in the tropics, South and Central America, and the western side of North America, we actually see temperature rises. Right folks, that's the intro out of the way. Time to get on with the theory. The Sun's solar cycle has stalled. In the long life of a star, this is quite a regular occurrence, with gaps of several thousands of years between each event. During this time, the Sun's output of heat and light is erratic, due to its surface becoming blotted with roaming large sunspots. The situation will resolve itself when the Sun expels a large amount of surface material. The Moon's orbit is far from perfect. From our perspective, it is constantly moving closer and further away, while the Earth's moving tilt gives the impression of the Moon travelling further north or further south. As Europe and North America are approaching their summertime, the resulting bulge in the Earth's surface will have a greater effect on this region. Multiple changes such as the balance of atmospheric gases, air currents and ocean currents are combining to bring the long ice age to a natural and gradual end. This has caused breaks in the frozen tundra surfaces across the two continents, allowing fungi and weeds to compete with long tundra grass that feeds animals such as the mammoths. Not only does this reduce the normal food source, it creates boggy areas that simply cannot sustain the weight of large animals. In a normal day, around 15 volcanoes are erupting around the world. However, the potential release of pressure from volcanic sites in the northern hemisphere has been suppressed by ice and permafrost. This is now melting, just as the Sun's erratic gravitational forces combines with the effects of the lunar orbit, both of which are shown to increase volcanic activity. The first sign of what is coming is probably a submarine eruption off the coast of the Azores. The sun's surface explodes, sending material in all directions. One such wave of plasma is on a course for the Earth, which collects and charges debris as it goes. The sun is reborn, and it bathes the solar system in bright hot rays. Less than 15 minutes later, the plasma wave strikes the Earth across the North Atlantic. This thins out the Earth's electromagnetic field while charging the atmosphere. This scatters cloud cover, just in time for the sun's fresh rays to hit. Everything in the region begins suffering the effects of severe overexposure to the sun. In the short term, this means the loss of crops, infections due to burnt skin, and an increased reliance by the humans on hunting. In the longer term, it will mean an increase in illnesses. Ravenous humans are not the only threat to the great beasts of Europe and North America. The open plains they rely on are changing fast. Rapid thawing of the tundra and the melting of ice is quickly turning valleys and low plains into bogs. The higher grounds don't flood, but with the water either draining downhill or vaporizing in the heat, the long grass is becoming dangerously dry. With the charged atmosphere creating massive lightning storms, the hills are wildfires in waiting.
But wait! There's more!
Everything from gravitational changes to the melting ice is unleashing volcanic forces throughout the two continents. From the Pacific coast of North America to the heart of Europe, and from the peaks of Iceland to the depths around the Azores and Canary Islands, eruptions become common. However, there is still plenty of ice to contain the most violent of eruptions, meaning most of what escapes is in the form of steam and gas. Air currents are affected by this buildup of heat. The swirling current south of the region drags vapour from the north into what is essentially an airborne river, which showers the Sahara and Central America. This isn't a catastrophe for everything. With no permafrost, heavy animals trampling saplings, plenty of soft wet ground, and a resurgence of sunlight, the southern woodlands begin to spread rapidly. In North America, woodlands don't spread. With no trees soaking up all the water, vast areas of North America become swamp-like. The land becomes so saturated that even the term land seems inappropriate. It begins to move, sometimes in big circles, influenced by moving air currents and even the Earth's rotation, forming strange features such as the Carolina Bays. All this heat allows warmer tropical waters to push further north, threatening to sever the ice fields of both continents from the Arctic. So, how did we go from to the ice that had covered everything volcanic in the region is gone, so now, when there is an eruption, it is no longer little more than a huge steam vent. Now it is far more powerful and throws up far more debris, filling the local skies around it with ash and dust. In Europe, vast forests that stretch to the edges of the frozen north conceals most of the continent's groundwater from the sun, which feeds massive wetlands. It also keeps the air between the trees remarkably still. This is creating the perfect environment for the cold northern air to flow through the woods, freezing much of the groundwater. At the same time, the North Atlantic is turning into a giant pinball machine with mixing of atmospheric and oceanic temperatures, creating massive storms, which bounce northwards between the two continents. These storms bring dense cloud cover and rain, which in turn protects the ever-growing number of icebergs, which combine with meltwater to cool the ocean, making it far more stable at a lower temperature. Sometime later, North America is pummeled by storms once the Atlantic has become more settled. Its wet terrain will replay what has happened in the Atlantic, although the effects are lessened and delayed. As a result of all this, what was once a huge bubble of heat spreading from America to Europe shatters, as the two land masses and oceans below become very different places, supporting wildly different climates. Well, that's 2 of the 3 changes that we've gone through, so we now just have the last change, which is what brought an end to the Younger Dryas. As mentioned, vast swathes of Europe were covered in wetlands, along with other green areas, along riverbanks and lakesides, fed for over 1,000 years by rivers of meltwater. But as the Younger Dryas freeze continues, and the forests grow more dense, less and less water makes it to these waterways. When the wetlands become deprived of oxygen in the water, the microbes that live there release vast amounts of methane. At the same time, with the water levels falling, riverbank plants begin to die, and when this happens, microbes release vast amounts of carbon. Meanwhile, in North America, the open grasslands and wetlands are even more extensive, producing far more of these greenhouse gases. At the same time, after years of relative inactivity, the volcanic cycle is coming into effect again, with occasional eruptions throughout the area. Simultaneously, iridium and other materials suggest some kind of light meteor or comet shower. The materials mostly burn up in the atmosphere, but the added friction is also helping to heat things up. The primary instigator of the coming change, however, is the Earth's climate. As Europe and North America froze, much of the surrounding area was getting hotter. Now, the imbalance between the 2 regions is once again causing storms as the atmosphere attempts to stabilize one last time. We have storms, volcanoes, lightning strikes igniting dead greenery, even falling stars. It's almost a repeat of what occurred nearly 2,000 years earlier, except for the solar storm. But this time, the solar storm isn't needed. This time, the Earth's climate isn't battling ice and permafrost that is thousands of years old. The ice is relatively fresh and melts quickly. This time, there is no big external force in action. It is all earthbound, driven by the world's climate. So when the atmospheric temperatures are reset, it is in balance with the rest of the world, establishing a long-term stability. And there we are, folks. That's the end of the video, and that's my theory. Now I know many will view this video and believe I'm simply sitting on the fence. However, the way I now view this incident is something akin to a drive up the motorway. All those vehicles, ranging from small cars and motorbikes right up to your big lorries, they drive around each other at different speeds, going on different journeys. They interact in the way they overtake, and occasionally they may come into contact with each other. However, for most people, it is quite a steady journey. However, when the factors play against you, well, thank you very much for joining me on this bus. Hopefully next time I'll have something nicer in the background to look at. Until then, thank you very much for watching, and I shall see you later.